Good morning, everybody, and welcome to the concrete repair webinar. We have still got people joining, but will make a start as we are on the hour now. This is the first in a series of the Ask the Specialists. It's run by the Structural Concrete Alliance, and as I say, this one today will focus on concrete repair. We have had a number of pre-asked questions, which the panelists will cover later on in this webinar. So just to run over some housekeeping bits, please feel free to use the chat. You will see at the bottom of your screen. I think we're all fairly well versed in the use of Zoom now, but yeah, the chat facility is at the bottom. There is also a questions and answers part of it as well, so either use that or the chat facility. That will be monitored throughout the webinar. So any questions that do come in, we will put them to the panelists at the end. Could I just remind all panelists to remain on mute unless you are speaking, given background noise, it can be quite noisy. If you guys would also like to turn off any background apps, it just makes the functionality of the webinar run slightly more smooth, hopefully. I just want to remind everybody about the Competition Act. Please, if there is anything contentious, put on the chat or on the questions and answers. We will be emailing you or messaging you through here directly. You know, this is all non-competition, so please remember that. I'll now pass you over to Paul Russell, who will be your host for this morning's webinar.
Thank you very much, Lauren. First of all, welcome to this morning's question and answer session. We hope that it's going to be informative. Certainly it'll be constructive, and hopefully it'll be educational as well. Now, as you're aware, concrete repair covers a wide range of topics, and we'll try and cover as many as we can today, but we know that it isn't possible to cover everything, but we're going to have further webinars in the future. Before we start, just a little bit about the Structural Concrete Alliance. This brings together the Concrete Repair Association, the Corrosion Prevention Association, and the Sprayed Concrete Association. And it was really brought together to provide a single coordinated voice of the source of reference for the structural concrete refurbishment and repair industry. So the Structural Concrete Alliance provides authoritative guidance on asset protection and repair, which obviously includes concrete repair, cathodic protection, and sprayed concrete. The Alliance actually represents 100 companies drawn nationally from contractors, manufacturers, distributors, consultants, test houses, and also equipment suppliers. And what we offer is basically a single contact or point of contact for major clients and a definitive source of information and advice for all those obviously involved in repair and refurbishment. Now, the Concrete Repair Association, which is hosting this morning's presentation, was formed 32 years ago in 1989 as a result of an initiative taken by a large number of leading concrete repair contractors who wished to really demonstrate their high standards and competency of workmanship and the technical ability as well. The CRA is committed to promoting and developing the practice of concrete repair, as well as other disciplines that go alongside that, as well as, of course, as advancing education, technical training, and health and safety matters in this specialist sector. Unlike the recent European Football Super League, the CRA is well established, and many of the founding members are still active members of the CRA. And those members include specialist contractors, product manufacturers, and distributors. By setting such self-regulating standards and procedures, engineers, authorities, clients, and other specifiers can select from established professional organisations for any type of concrete repair project. Well, today, the panel that we're going to introduce to you in a moment has over 100 years collective technical and practical knowledge in the repair of all types of concrete structures. So let me introduce you to the panel. The first one was hoping to change to the next slide, but here's myself, Paul Russell. As you can see, I work for MAPE. I've been in the industry for 41 years. The last 33 years, I've been involved with concrete repair, first as a contractor for a short time, but lastly, for the last 31 years, working for material manufacturers, working for MAPE for the last 10 years. I'm a product manager, looking after concrete repair and structural strengthening. Outside of work, my interests include supporting one of the 6 Premier League teams that attempted to join the Super League this week. I won't tell you which team. I also attempt to play golf, and I'm also a voluntary mentor for the Her Majesty's prisons, teaching life skills to Cat A prisoners. Can I introduce you to our next panellist, which is Paul Rigby, who will introduce himself.
Good morning, everybody. Thank you, Paul. Paul Rigby. I work for Sangamon Webber as a technical consultant in the infrastructure team. Been working in the industry for 33 years, joining originally SPD Construction Products in 1988, which later became Sangamon Webber. And in that time, I've been involved in the technical department and predominantly product training in the refurbishment industry, in concrete repair and composite strengthening especially. Outside of work, my family, rugby and golf are my favourite sports, but my main passion is kayak touring and camping along riverbanks and lakes and the coastline. So that's enough about me, and I'll hand you over now to Chris Orme.
Hi, good morning, everybody. I'm Chris Orme, National Specification Manager for Fosroc International. I have over 20 years experience working for various manufacturers in the construction industry, and I've been involved in large, small, medium projects across the UK, Ireland and Europe. What I love best about the construction industry is when you get up in the morning, you never know what challenges the day is going to bring. It's this variety in the projects and challenges that we face that keeps me enjoying working in what I think is the best industry in the world. So I'm sure you'll agree with that. I'll hand you over now to Richard Bailey.
Thanks, Chris. Good morning, everybody. Yes, I'm Richard Bailey. I'm the director of Balvac. I've been in the industry for almost 30 years, all of that time with Balvac. I've been leading the business for the last 12 years. We work predominantly in the highway infrastructure and power sector, undertaking structural concrete repair, strengthening and protection works to existing assets. I'm absolutely passionate about health and well-being, training and development, and driving a focused approach to innovation, collaboration and lean thinking. And just as a reminder, Balvac is a wholly owned subsidiary and an agent of Balfour Beatty Group Limited. So we're part of a large backing, and that's served us very well over all my time working with this company. Outside of work, family man, and very into my football, like Paul, supporting one of the top 6, although my support wavered momentarily this week. I like to play football. I like to get out walking. Thank you.
Thank you, Richard. So we're now going to move on to our questions. First of all, we'd like to thank you for sending the questions in, and hopefully we'll be able to answer them to your satisfaction. So let's move on to our first question, which is, what are the determining factors when choosing a concrete repair system? Perhaps Paul Rigby, you'd like to take this first?
Yeah, I can take that one, Paul. Thanks for that. Firstly, I'd get an understanding of what caused the defect. Was it a physical problem, mechanical or chemical attack? I try and also specify BSEN 1504 compliant sort of product system, but also understand what is the environment, the size of the repair, the history of the structure is important. That'll tell us a lot from a survey, and in short, get a structural survey. So yeah.
Thank you, Paul. Richard, have you anything you'd like to add?
Yeah, I'll just add to that. What's key really is what are the client's requirements? It's not just about the technical aspect of the system. What are the client's requirements? What is the actual outcome? What is the problem? Are we looking to restore the physical dimensions, the durability, the integrity, the strength? There's all these factors to consider. All of those will be taken into account when deciding what type of concrete repair system. Also, as just been said there, the environment. Not just the environment that the structure is exposed to, but also the circumstances upon which the repair will be undertaken. Access arrangements. So there's lots and lots of things to consider.
Good, thank you. I think we've covered that one quite well. Can we move on to our second question? It's an interesting question, this. Do cracks in concrete need to be cut out and repaired? Perhaps we'll go back to you, Richard.
Okay, yeah, I'll avoid the sales pitch, but the straight answer from me would be no, not necessarily. They don't have to be cut out and repaired. There's numerous types of resin injection techniques and products that are available to restore the integrity, strength, and durability. Clues in the company name with Balvac, but vacuum assisted resin injection will definitely provide a greater chance of completely filling the crack depth, and can be used to pull material to specific areas of a crack. So that's really going to try and ensure that you get a full resin penetration of the full void matrix. So yeah, resin injection is definitely a tried and tested technique that can definitely alleviate the need to cut out and repair in many circumstances.
Okay, could you just ask a supplementary question on that, please, Richard?
Yep.
How do you check afterwards to ensure that the injection material has actually got into the crack? Is there any method you use?
Thank you for asking that. Yeah, because I'm passionate about that with everything that we do in our business. It's wherever a destructive test can be undertaken, i.e. an intrusive test, a core. Taking a core through a crack is a fantastic way of demonstrating full depth penetration. If that's an absolute no-no, depending on the structure, then there's various non-destructive testing techniques that can be used, ultrasonic pulse velocity and one or two other things to determine the integrity of the filled crack.
Good. So I think it's important that we ask the expert, isn't it? Good.
Mm-hmm.
Let's move on to question 3. And we're going to ask Paul Rigby to answer this question. Can microconcrete be used for repairs and therefore feather edge the perimeter of the repair zone?
Right, the short answer on that one is yes, it certainly can. Microconcretes can be used very successfully in shuttered environments because obviously the fluid materials. Generally where you've got congested reinforcement as well. Over a metre square, I'd consider using them. Feather edging in any repair sort of situation is not ideal because the feather edging becomes a sort of planar weakness. So I'd always try and work to a well-prepared edge, which it can be difficult in some situations, and I'm sure Richard might want to sort of come in on that and to back me up on that maybe.
Yeah, absolutely. As a contractor, we are reliant on the support and advice from our technical experts from the material supplier fraternity and also the designers, specifiers. But yeah, a well prepared edge is traditionally achieved through saw cutting. And BS EN 1504 requires us to work to a well prepared edge. And this might be achieved through using a percussive or pneumatic breaker, but whether it's a saw cutting or a pneumatic breaker, in both cases you're generally holding a tool in a hand, and that's something I'm sure we're going to cover a little bit more. But we want to get rid of that situation and take the tools out of people's hands. So this dilemma of do we have a well prepared edge prepared in a very traditional way using these tools, or do we use the technology of advancing materials to allow us to feather edge? We've got to get that balance right as an industry.
Good, thank you for your answers. Can we move on to our next question, which I'm going to ask Chris Orme to cover. With the concrete industry looking at non-cement binders to lower their carbon footprint, Should the concrete repair industry be pushing hard for similar developments for our cement-based repair products? Over to you, Chris.
Okay, cheers, Paul. I think this is, absolutely something that we should be looking at. I think, the good thing is, from our point of view now, is we're getting more and more environmentally friendly raw materials that are becoming made available to us. And one of the things that we've done at Fosroc for a long time, and other manufacturers, we've used supplementary cementitious materials in our repair products, such as ground granulated blast furnace slag, pulverised fuel ash, and also limestone in the manufacture of the repair mortars. This, in effect, reduces the environmental impact of these products, since less cement is used in the production. We also use, in some of our products, a blend of cements, one of which is calcium sulfoaluminate, and that's obviously produced using less energy than Portland cement. So obviously we are, as an industry, I think, looking at this, and it is something that's very important to us.
Yeah, that's good. And obviously these types of materials are evolving all the time, and as time goes on, we'll be bringing, as an industry, more and more products with this type of technology will be available. Good, thank you for the answer, Chris. Let's take our next question, the fifth question. What measures are being put in place to be more sustainable? This is a question that we quite often get asked within the industry. So perhaps, Paul, would you like to start us off with this?
Yeah, I can come in with that if you want. Sustainability, I suppose from my company's perspective, they're very passionate about commitment to providing a working environment which is healthy and safe for all, as well as actively promoting the protection of the environment. This approach supports our overall ambition to achieve zero harm across all our operations, and that's because within the industries as well that we work with. From a product sort of perspective, we're passionate now about reducing packaging, because if you think about the amount of packaging that leaves manufacturing plants in the form of bags, 25 kg bags. So we're looking at introducing more bulk delivery systems in silos, and the coatings in mini bulk containers as well, which then can be recycled back into the manufacturing chain. So that's being developed as I speak today. So yeah, very passionate about that indeed.
Good, thank you. Would Richard like to come in as well, please?
Yeah, as a contractor, we're working with ever more demanding customers. Take Highways England as an example there, and we've now placed a strategic approach to achieving carbon reduction targets right at the top of our agenda, and we will be asking everybody who works with us, all our supply chain colleagues, to update us on their advances in material composition and the likes of the improved packaging and transportation things that Paul's just mentioned there. We need that, because we've got a report on carbon reduction targets going forward. So there's a few things to consider. There's the more obvious things of the packaging, and reducing the use of diesel powered equipment on site, and off-site manufacturing if we can, and reducing the effort on site. But also things like let's try and work out ways of minimizing the amount of concrete that's to be removed in the first place. That might seem slightly paradoxical for a concrete repair, for the concrete repair industry, but that's where we've got to move to. Are the techniques to enhance and restore what's already there. Don't remove and replace things unnecessarily. I'm not saying that people have blatantly done that in the past, but the traditional approach is take out all the obvious defective concrete, take out a bit more, make the repair area that secure and correct, and then place the materials back in. Let's see what we can do to try and minimize that.
Yeah, good points. Chris, have you anything you'd like to add to that?
No, I just echo really what the guys have just said. I think that we are becoming more and more sustainable as an industry. It's obviously very much more important now for the clients and people at Highways England, for us to be more sustainable. we at Fosrock, obviously, we're trying to do, as much as we can do to make, our products, raw materials, and, things to be more sustainable. One of the little things that we've just done, for example, is change our company car policy. We're all going to be driving electric or hybrid cars from now on. Obviously it's a small step, but given the amount of miles that, we drive as an industry, hopefully that will help to, in the longer term, will help to lower our carbon footprint.
Yeah, good. Thank you for those points. We have certainly introduced solar panels or solar power at our factories, and that actually allows the machines to run and powers the lighting, etc. So therefore helping just to bring that carbon footprint down a little bit. Let's move on to our next question, question 6. Interesting question this. What are the remedial solutions for low concrete cover? And perhaps Paul, would you like to take us on that one?
Yeah, an effective product for that is probably the use of a fairing coat. And the beauty of fairing coats, you can use them in new build and refurbishment. And for those who are not familiar with the term fairing coat, it's basically a cementitious skim, a sort of smoothing compound, which generally applied at 2 to 3 millimeters and has been accepted by the industry for many, many years. That will give you theoretically 20 mil of extra cover. So if you double that up, you can very quickly get to a 40 mil sort of cover with that application of material. And also you could consider protection of your concrete surfaces also with hydrophobic sealers, because they are very good at shedding water. They're also good at resisting chlorides. So hydrophobic sealers could also be considered in these sort of environments. Okay, is that okay?
That's fine, thank you. Good. Let's move on to our next question, which is one that we get asked a lot, or the contractors certainly get asked a lot within the industry. What is the CRA doing to promote the reduction of HAVs and silica dust risk? Perhaps Richard, you could answer this question.
Okay, yeah. So the industry must target taking the handheld tools out of the operator's hands completely. I'm very clear about that. I mentioned that in response to another question. And I said right at the top of this webinar that I'm passionate about this subject. We're all working hard, and we must all support one another to identify smarter ways of working to reduce the risk of any of our operators developing hand-eye vibration syndrome through being exposed to vibrations. So we need to look at automated solutions for raking out the concrete. That could be remote controlled electric robotic breakers, robotic units, pneumatically dampened and controlled air driven breakers. Hydro demolition is very well established, and in lots of circumstances it's a very appropriate way of breaking out concrete, and again takes the tool out of somebody's hand. In all of this, just linking back to the previous question, we've still got the preparation of a good edge to a concrete repair to achieve. So we must work out how we're going to do that without holding a tool in our hand. And very much linked to the last response on the sustainability topic. Let's minimise the amount of material to be removed and replaced in the first place. Remove the effort, or reduce the effort rather. Yeah, look at alternative techniques to enhance, strengthen, and protect. On the question of silica dust, well, silica's a product that sits within cured concrete and is released as dust when it's cut or broken with a breaker. And again, the answer is very simple. All dust must be fully suppressed. End of. Vacuum extraction at source or water suppression attachments to tools that are used. And everybody must remember that PPE is not the first, it's the last line of defense. Yeah, so of course people will be wearing FFP3 masks whenever they're undertaking these operations, but not to primarily protect them from dust that is going to be airborne. We must eliminate any airborne dust completely. It's only there as the last line of defense.
Thank you for that, yeah. And it's good to see that the Concrete Repair Association are at the forefront of adopting these methods and promoting them, whether it's through the actual workmanship, but also within our seminars or our CPD presentations that we highlight these potential problems. So the client, excuse me, is fully aware of these, and you can see that the contractors who are members of the CRA should be following these guidelines, and they do. Can we move on to question 8, please? Is concrete repair just for refurbishment, or can it also be used in new build projects? Perhaps Chris, you could take us through this one, please.
Yeah, thanks, Paul. We think around about 50% of concrete repairs that are carried out in the industry are done in new build. So obviously, a big part of the product that we produce certainly goes into that sector. We're often required to look at situations in the new build construction, and some of these areas include cracks, which obviously we've covered off, low cover to reinforcement as well. We also get things like honeycombing, shutter removal, damage when shutters are removed, pinholes, rain damage to slabs, voids and mechanical damage. So obviously there's various things that you can do to repair the damages and issues that you have, but obviously it is a big part of certainly what we do at Fosroc every day. So yeah, it's for both.
Good, thank you. Yeah, it's the same with the company I work for. We get involved with new structures as well, particularly precast panels that have perhaps been damaged in transport, tunnel segments that where the shutters have been stripped too early, or they've produced honeycomb concrete. So yes, we do a lot of work on new projects as well, obviously, as a lot of repairs on bridges, buildings, and other civil structures. Let's move on to number 9, please. This is a question from one of those in attendance today. I'm interested in learning about the roughness measurement of concrete substrate preparation systems, in particular the possible implementation or use in Europe of the ICRI's CSP, which stands for Concrete Surface Profile Comparison Templates, versus the R values of airport runway reference values using the sand disk method, particularly for flooring applications. But if you can just move to the next slide, please, we'll see what the profile that certainly the American and the Australians are using at the moment, and it's something that we have started to use in our specifications, in our recommendations. We can see here on the slide is this particular one is CSP 6, which shows the roughness of the prepared concrete. Why do we need a rough surface? Well, the aggregates that we use in some of the repair mortars, some in microconcrete, obviously very, very small, perhaps 0.2 of a millimetre. But some of the heavier repair mortars can be anything up to 2.5 millimetres. So you need a good surface amplitude. And this is really what the standard is asking for. And it is starting to be accepted within the UK and other parts of Europe. With regards to the R value on the airports, this is something that tends to be used for coatings, and it's slightly different to the CSP standard that we can see in front of us. It's something personally that I've not really been involved in with regards to the airport runways, apart from knowing that there is a certain amount of amplitude needed for things such as skid resistance, etc. But really, this type of system is something that we would, as an industry, want to promote. We want good adhesion for our repair mortars, whether that's my competitors or ours. We want them to stay there. The industry needs to continue to have a good name. We don't want to be repairing airport runways or other buildings because we haven't prepared it properly. So following these profiles is something the industry is adopting, and it's something that we know we'll take to heart very, very quickly. Let's move on to our next question. this is a very topical question. How does Brexit affect material supply? Tying that in with how has COVID affected material supply, projects, etc. And what about the wider impact? As you can see, it's quite a big question to tackle, but let's have a go at it. So perhaps I can ask Paul, if you would like to start us off, please.
Yeah, I'll have a stab at it. Yes, I suppose the uncertainty of it all provided many of us with sleepless nights, didn't it? I think manufacturers using locally sourced materials and raw materials has lessened the impact, especially from my perspective of who I work for. And I think we were affected when COVID initially hit and we went into the first lockdown, because the uncertainty, safe working practices had to be sort of quickly introduced. But we quickly, as an industry, I think, sorted ourselves out, and I don't think supply chain was interrupted that much from my perspective. But if anybody has suffered from it, then please let us know, because it is an interesting topic. But, has anybody else got anything to say on it?
Richard?
I'll just, I can add a couple of things there. From a specialist contractor point of view, we employ our own workforce and carry some of our own equipment. So Brexit in that respect has had little or no impact on us, but we are mindful of the the risk of supply issues, import issues for raw materials or completely manufactured materials coming in from parts of Europe. That's definitely an issue. It's not just an issue of supply, but it can be an issue on price as well. If scarcity is increasing because of the delays. I noticed in conversation only yesterday, not quite concrete repair, but very closely associated, cathodic protection, some titanium mesh material. There's just the price of the titanium mesh just shooting up, and that's clearly impacted by these issues, Brexit or COVID, in terms of supply and other reasons. So yeah, we're concerned as a contractor. We need to know what the material manufacturers are able to do for us to secure product, both in terms of availability and the right sort of prices. In terms of COVID affecting the projects, again, from a contracting point of view, I've been amazed at how we've adapted over the last 12, 13 months. Our own business has been affected very, very little, because we've just taken such a tough approach to dealing with COVID. We've managed social distancing on site brilliantly, as I'm sure many other people have done. It's become a new way of life. Operations that would have had people huddled together undertaking works have now been rethought through so that we stay further apart. So from a project operational point of view, we've just adapted brilliantly as an industry, and I'm proud to have been part of that.
Good, thank you. I can echo those words, Richard, because I was involved in one of your projects, and it's the first time I've had to stand 2 meters away from the foreman, which was quite nice. Chris, have you anything you'd like to add to that?
Yeah, I think Brexit obviously has affected supplies, as same as Paul. We make a lot of material in the UK, but obviously it's not just you make raw materials in the UK, but obviously your supply chain may come from other places in the world as well. So obviously Brexit does affect things quite a lot. In terms of COVID, I think it's been great, how we all have, been able to manage this, both from an on-site and off-site sort of communication sort of point of view. Obviously we've used Zoom, we've used Teams. I think, it's been good to use these sort of methods as well, because, keeping in touch with contractors, projects on site and things like that is vital to what we do as an industry. And I think that's been great that we've all done that. COVID has affected projects, it's pushed things back, and it's been really bad for the whole, for everybody. But I think, we've come through it. Well, we're coming through it now, and I think that hopefully we're going to be out the other side of it very soon.
Yeah, thanks, Chris. Certainly from my perspective, the worry we have is raw material supply. Things such as cement, for example, is starting to become in short supply. That was reported only last week on the Concrete magazine. Some aggregates are difficult to get hold of. So really, it's planning ahead to make sure that we have enough of these materials in stock, so we can make the materials that are needed for the sites that we're working on. As regards wider impacts, things such as fires in chemical plants haven't helped. That's also increased the price of some of the raw materials that we use in some of our materials. So there will be a wider impact, with no doubt about it. We don't know the full picture yet, but early notice is something that we really need, so that we can plan to ensure that materials reach the correct places, or the suppliers, the distributors, etc. On time. So let's move on to our next question now, please. And interesting question. What is the lifespan of a concrete repair? And we'll ask Paul Rigby, please, if you can answer that question.
Yeah, I believe if it is executed properly, and you carry out surveys, do the proper diagnosis and issue the right specification, followed by quality preparation and application, I would expect a repair to match the life of the building or the structure. But again, we have to take into account and consider the environmental impact and the exposure that structure is going to get, and the products and the systems that are going to be applied onto the structure. Most manufacturers will give you guarantees. I think a key factor in this sort of stuff is early engagement from the time that we're doing the surveys to during the actual performance of the system over its lifespan. If you see issues, then you call people back in. They might be able to give you some good advice on how to head things off. So early engagement is a massive key. And I know Chris is going to talk about that very, very shortly. So I think it's now, actually.
That's the next question. So let's move on to the next question. So Chris, what are the advantages of early engagement?
I think that early engagement is key. We find that when we engage early, that that's where you get successful projects. I think that having a clear project brief from a client with their needs and expectations for what they're looking to achieve on the project, that should be shared then with all the stakeholders who are going to be carrying out the project. So your structural survey people, your client, your specifier, your main contractor, maybe your specialist contractors and product manufacturers. It's about collaboration, and being able to deliver a successful project depends on clear communication between all parties, and having regular meetings throughout the project from the inception to the completion. Let's have clear lines of communication, a clear project brief, good survey and testing done, and I think once you put all that together, that gives you a successful project outcome, hopefully.
Yeah, I think I agree with that. Another advantage as well is quite often when we look at a structure, there can be various ways we can repair it. There can be different types of materials we can use. So at early engagement, if there's the possibility of doing a trial with different methods, and then we can together as a team, whether it's the material manufacturer, the contractor, the client, the engineer, can decide on the best method for that particular structure, which I think is also very important. Let's move on to our next question. Again, another interesting one. What is the repair material to use for big concrete spalls of beams and columns? And a supplementary question to go with it. How can we join new reinforcement bars to existing ones which are cut and need to be replaced? So perhaps we can ask Paul Rigby, please, if you'd like to start us off with that.
Yeah, for mass concrete repairs, a large volume reinstatement. Flowables are good, which are classified as micro concretes. Recasting concretes is another terminology you could use. Cubic meters can be done, pumped or poured within hours. Also spray concretes, wet spray, dry spray options. You can spray 3 to 4 cubic meters within an hour. So it's very quick install. With regard to reinforcement, joining it together, generally within the industry, we look if 10% of the mass of the steels have been eroded away, corroded away, then we look to replace or supplement that steel. And that can be welded on, it can be spliced on, but you've got to consider the actual lap of what you're doing from a weld to the lap, and when you tie it on, it should be 15 times the diameter of the bar, or around about 300 millimeters, depending which is the greater equation. There are other reinforcing connections that you can use, which I think Chris is going to talk about very, very shortly. So I'll hand over to Chris.
Thanks, Paul. Yeah, you have suitable resin systems you can use to bond or, connect to ties as well. But I think, coming back to the repair materials, what method you use depends on, obviously, the size of the repair, the location and the environment as well. You might have a tidal area or something like that. So, you might not be able to use a traditional hand applied method or something like that, or you might need to use rapid setting materials and things like that. So I think that, doing a good site survey, discussion with the project design team, and that, gives you the understanding that you need and the requirements to sort of move forward with which repair material and which method you would use moving forward.
Thanks, Chris. Richard, have you anything you'd like to add to that?
Yeah, I certainly endorse what's already been said there, and linking it. You can link all of these questions and the responses that we're like giving to the previous question about early engagement. It applies every time. The earlier that we understand what a problem is, the more likely we are that we can develop the best solution together. So there's lots of different possibilities that have just been highlighted there, and I completely endorse those. The production rate that Paul mentioned for spray concrete is probably relating to wet spray concrete and mass fill. A dry spray concrete will be slightly less production, but it will give you a rapid set, high strength structural repair where that spray concrete can get through the existing rebar. So that's certainly one quick way of mass filling beams and column repairs. Couplers have been mentioned there, and different ways of extending and adding new reinforcement. Resin bonding has been mentioned. So we just got to get the balance right between do we resin bond or couple of new rebar in there because we haven't got the space to open it up, or have we got the space to open it up and get the standard length requirements in place depending on what the specification says. If we're adding couplers or putting resin bonded bars in, there might be a requirement for a departure from standard, depending on what the structure type is and what the specification that we're working to. So that's something to be mindful of.
Good, thank you. Well answered. Okay.
I'll just add something there, Paul. Actually,
Please, Paul.
Just thinking about it. If you've got loss of reinforcement through corrosion, then another consideration could always be composite technology, where you're adding carbon fibre to the outside of the structure to strengthen it. So that's something also you could consider. And there's plates and wraps that different products you can use. So yeah, composites is something you could always look at.
Good point, Paul. Yeah, I mean, again, linking us back to one of the previous responses on sustainability. If we can avoid taking all of that concrete out in the first place through innovative techniques, let's think about it. Why not do that?
Carbon fibre, glass fibre bars, basalt bars are also available to replace the corroded ones. But again, an engineer would need to be involved in the design of that. Let's move on to our next question, which is quite a taxing one. What products would you recommend for an existing swift, long-lasting concrete repair of, say, a 300 by 300 millimetre patch within a sewage work inlet channel beneath the dry weather flow or the tide line? Also, is overpumping of the sewage a given, or that there are other ways of doing the repair work but still achieving a long-lasting repair? And then to go along with this question, it's obviously talking about sewage works, to the top of the wall head of a secondary settlement tank, where concrete is often less durable and where operational staff often spread salt to reduce the risk of freezing, slipping of rotating bridge. What are our recommendations for that? Perhaps, Richard, you'd like to start us off on that one? Yeah, you're muted, Richard.
Sorry. Yeah. That's because I'm thinking about my response there, Paul. Yeah, no, thanks for that. Well, there's a number of technical product solutions that can be looked at there, but again, it's about access, isn't it? You know, can we go and undertake a long-lasting repair, and not overpump sewage? I wouldn't fancy it, if I'm honest. You know, I'd prefer to have an environment that's clean and accessible for us to undertake any kind of structural repair. That's the first thing. I think it would be an absolute last resort to be trying to consider working in and around such an environment. Perhaps Paul or Chris can maybe recommend actual the products that from their range.
Yeah, there's various products that could be used. I think, just to move it on slightly, in this situation, I think it's imperative that a site visit takes place. There'd be lots of factors that both the contractor and the material manufacturer would need to consider to give you a long-lasting repair. Sewage pumping stations are aggressive in what they pump out. They damage concrete quite easily. So really, we need to look at this and come up with a solution. It's not as easy just over a screen just to give a definitive answer. So I guess really visiting site and then come up with a solution might be the best option. So you, Paul or Chris, agrees with that, or anything else to add?
Yeah, I think, like I say, with that one, Paul, I think, you know, like you said, the site visit is key. You know, getting a good idea of what's going on in the area. You know, there are products that you could, you know, put down onto, you know, the bridge or something like that to improve slip resistance on the deck, rather than, you know, have to spread salt and things like, you know, deck coatings or something like that. But I think, yeah, it's a site visit that's needed.
Yeah, I mean, from my point of view, you could always look at highly durable materials such as epoxy resins. You could even consider polyesters for small local repairs, but epoxy resins would be good for a good chemical resistance, but they're very expensive. You could also consider cement-based materials. Sulfate resistant cements are very sort of hard to get hold of these days. So if you're going to use a cement-based material, I'd look at choosing an R4 type mortar, a structural material. Keep your water cement ratio down to about 0.45, and then you can then treat the surface of that once it's cured with protective sealers. Hydrophobics are very good as a protection. And yeah, always create a non-slip surface on something, and again get a sealer down or a coating with non-slip. So that would be my sort of take on that sort of question.
Just to come back on the specifics of the first part of that question, you know, clearly we're not talking about a large patch. So what you've said there, Paul, about the alternative resin-based products, as you say, high strength, hugely durable, very expensive. But if we're talking about a small area, perhaps that's the right way. You know, perhaps that's the right solution. You know, understanding the environment fully will help us with that. And what we'll probably find is in that very specific circumstances that the vast majority of the cost and time spent repairing that you know, putting that solution in place is probably going to be down to the access.
Absolutely, yeah.
I think the other thing as well is obviously with something like that is possible that, you know, you might need to do a survey on the whole area, because obviously if there is other areas as well, if there's a 300 by 300 mil patch, then there's good chance there's going to be other areas as well. So undertaking a good survey would be applicable as well in the area.
Yeah, you also might want to consider some of the cementitious products that are sulfate resistant, perhaps have polypropylene fibres in them. So there's lots of things to consider. So yeah, a site visit without a doubt is really what we need to talk about. We've got some questions that have been asked by the audience. Perhaps Lauren, could you come in here?
Yeah. Just a very quick thank you to everyone that has contributed on the questions and answers. Obviously, these questions that the guys are answering at the moment were pre-submitted, but we will get through as many as we can on the chat. I'm mindful that we are coming up to the hour. Anything that isn't answered live now, we will do a recording post this of the panelists to answer the questions that are on the chat and the questions and answers section. So please don't worry, your questions will be answered, and the recording will be available to you. We will email it out as a link. So guys, I have a first question on the chat is, how do you repair concrete floor joints? So I don't know who wants that one.
Okay, I'll take that one if you like.
Thanks, Paul.
Preparation is absolutely key when you repair floor joints. The joint's obviously broken away, it's spalled, possibly because of vehicle traffic, maybe stacker trucks if it's in a factory, or other vehicles if it's on a highway or a road. So preparation is important. Cutting out the defective area, working to a square edge, particularly on a floor joint. Feather edging I wouldn't recommend because of the type of traffic that's going onto it. And then using a compatible repair material that is compatible with the existing parent concrete.
I recommend epoxy mortars quite a bit in that sort of scenario, because you don't have to take away so much concrete. You can keep it quite small in dimension. So epoxies are very good at repairing edges of nosings to expansion joints and floors, definitely.
I'm guessing with the nature of the question, you talk about floor joints, we are talking about an industrial or warehouse type environment. And one thing to think about is the stability of the actual slabs. We've undertaken a lot of work in the past to not just repair the arises around a warehouse floor joint and then the joint itself, but also to fill any voids that might exist underneath. The load that's applied on the edge, an aris edge of a concrete joint from a hard, small wheeled piece of kit like a forklift truck is quite considerable. And those impact forces can cause the aris repairs, but they can also, if you've got voids underneath, you can also get minor deflections in the slab. So let's look to stabilize the area around the joint.
I think obviously the other thing to consider as well is speed of installation. In this, sometimes these warehouse environments are very highly trafficked, and they need to get on the floors very quickly as well. So it could well be that you could look at using sort of some fast set repair materials, and indeed joint sealants and things like that later on if that's what you need to do as well.
Okay, thank you. Okay, Lauren, another question?
Yeah, so next one is, if a water tank will have GRP lining, what kind of repair is recommended before GRP? Don't all rush at once.
I'm assuming that the GRP line is going to be added in after the repair. If that's the case, and it's not repairing the GRP, then a traditional concrete repair mortar should be sufficient for it.
Okay, I agree with that.
Yeah,
I was going to say the question might be leading us to think about the compatibility and the cure time. If there is time for full curing before a resin-based lining or GRP lining is applied, then which will be bonded, I guess. Then yeah, it's traditional cementitious would work, but we might need to look at other products if we're talking about a a limited possession period inside a tank where we've got to move very quickly from one operation to another. But certainly, it's the surface preparation and repair in the most traditional sense is needed first to restore the integrity and the profile of the tank, of the structure, before the lining goes on.
Yeah.
Right.
I've got one here that's fairly topical. Everyone's, it's not something we can get away from at the moment. Back to COVID. Somebody asked, how are the industries really going to deal with job recruitment, especially in construction? I think it's a $1 million question, really, isn't it, across every industry? But
yeah, it's a tough one. It was tough before COVID, to be honest. Attracting the interest, a new generation of people into the industry. It's certainly a challenge that we face as a contractor. Bringing people in, post COVID, we hope that we can open up opportunities. I mentioned that we're a Balfour Beatty Group company, and there's lots of very group-wide initiatives that are being rolled out. Armed Forces Covenants. Balfour Beatty is a founding member of the 5% Club, which is trying to bring apprentices, graduates, trainees into the industry, and we're measuring targets that we've set ourselves for that kind of thing. But it's about attracting people into an industry that has operated in a very traditional way. So some of the other responses that we've given so far, again, link into this: sustainability, health and well-being, technological advancements. These areas, if we're focusing on these areas for all the right reasons, they should all help to provide an attractive environment for bringing people into the industry.
Right. Shall we move on to the next question?
Yeah, do you want to do one on the chat, Paul, or would you like to do
one more on the chat then?
Yeah. Okay, so I have one from Paul here. Thanks, Paul. Where you mentioned adding 15% to existing rebar when doing multiple repairs in small areas, will this have a noticeable impact on the SE's concrete crack width design? Bit of a mouthful there, Paul. Thank you for that one. Anyone want to take that one?
I think
that's a thinker.
I'm a visual learner and I can't see where that's written down. Sorry.
Maybe one to answer after on the recording after. It's always easier when you've got them in front of you rather than after you. So yeah, Paul, we'll come back to you on that one after the webinar.
Okay, so let's move on to our next question. Actually, we need to wind up fairly soon, don't we? Question 15, which is when should galvanic anodes be used in repairs? Well, can I invite you to come along to our next seminar in 2 weeks' time, which will discuss this subject, we'll discuss part of this subject, but you'll get the answer to that one. So it's just a little bit of a teaser to get you to come to the next one. Can we take the next question, please? How necessary is it to cure repairs, and what are the options for curing them? So perhaps, Paul, would you like to take that one?
Sorry, can you just repeat that, Paul? Sorry.
Yeah. How necessary is it to cure repairs, and what are the options for curing them?
Very necessary, really, because especially obviously if the cementitious materials, very necessary. Obviously, if they're resin based, then you don't need to worry about it. But yeah, cement based materials, you want to try and keep as much moisture in that repair area as possible. A lot of traditional methods are still used in curing, such as dampession, polythene sheeting. It's difficult to keep on a building or a structure, so dampession is good. But there are materials out there which can be solvent, white spirit based curing agents can be put over your repair compounds. They need to be removed if further applications are going to take place. And there are also acrylic based materials now available, which will act as a primer before any coatings go on. So yeah, curing is very, very important. Very important.
Yeah, good. Thank you. Okay, well, we're mindful of time, and we'll wrap this up now. There is still a lot of questions that we haven't had chance to answer. In autumn, we will be holding another Ask the Expert session, and this is a general invite to any of the members of the CRA who would like to be involved in that next session. Then just obviously let Lauren know about that. So in 2 weeks' time, on the 29th of April, sorry, it's next week, in a week, we have the Corrosion Prevention Association webinar. It's a very similar format to what we've seen today, but obviously answering questions on anodes, cathodic protection, etc. And then on the 6th of May, the Spray Concrete Association will also be holding a webinar, and we would you're very, very welcome to come along to those and to obviously submit questions as well. We're looking for your feedback, and if you can fill in the feedback form that will be posted at the end of this presentation, we can then look at those feedbacks. We can improve, because we all want to improve, but we can only do that with your help. So it's important that the feedback forms are filled in. And we're going to give a prize or a raffle of a Amazon gift voucher, £20 Amazon gift voucher to the lucky person, a raffle prize. So this really just brings us to an end. I'd like to thank the panelists for their hard work. Really enjoyed the answers. It's been a pleasure working with you. And we hope that you as the audience have enjoyed and you've been informed and educated or had your mind opened when it comes to the repair of concrete. Remember, the Concrete Repair Association is here to help you, and please get in touch if we can do that. So thank you very much, and we'll conclude our session today. Thank you.
Everybody.
Thanks.
Thanks, guys. Well done.